In this video, I will introduce the normal distribution and the standard normal distribution. The objectives will be to interpret graphs of normal probability distributions and how to find the areas under the standard normal curve. A continuous random variable has an infinite number of possible values that can be represented by an interval on the number line. For example, the time spent studying can be any number between 0 and 24. Okay, so you don't study for exactly 3 hours. You might study 3 hours, 24 minutes, 5 seconds, 7 nanoseconds, and so on. So that's why they consider that a continuous random variable. It's the time is continuous. The probability distribution of a continuous random variable is a continuous probability distribution. So we'll talk about the normal distribution. A continuous probability distribution for a random variable x is one of the most important continuous probability distributions in statistics. And the graph of a normal distribution is called a normal curve. When the graph is all the way symmetric, the mean, median, and mode are equal. Sometimes the graph may be closely symmetric but not exactly symmetric, but in the case the mean, median, and mode will be approximately equal. The normal curve is bell-shaped and is symmetric about the mean. As you can see, I have the mean here in the middle. If you see this line going right in the middle, that's your peak. That will be your mean. If you were to fold this graph in half, it will be symmetric. Both sides will meet up. The total area underneath the normal curve is equal to 1. The normal curve approaches but never touches the x-axis as it extends farther and farther away from the mean. So as you can see, I have these circles drawn. The graph goes closer and closer to the x-axis, but it would never touch. If you have a mean and you go out one standard deviation below and above the mean, the graph curves downward. The graph curves upward to the left of mean minus the standard deviation and to the right of mean plus the standard deviation. The point at which the curve changes from curving upward to curving downward are called inflection points. A discrete random distribution can be graphed with a histogram. For a continuous probability distribution, you can use a probability density function, or a PDF. A PDF has two requirements. The total area underneath the curve is equal to 1, and the function can never be negative. So here are examples of a few normal distribution curves. They can have any mean, and they can have any positive standard deviation. The mean, once again, is your peak. That's the location of the line of symmetry. The standard deviation gives you the spread of the data. So if you look at the first two graphs, they both have a mean of 3.5. But as you can see, one is skinny and one is fat. So the one is skinny has a smaller standard deviation. It's 0.7 because most of your data is gathered around that center point. Whereas the one to the left, it has a standard deviation of 1.5. That means the data is more spread out about the mean. If you look at graph C, that has a mean of 1.5 and it has a standard deviation of 0.7. So as you can see, B and C have the same shape, except they have different means. So in this example, it's asking us which curve has a greater mean. If you look at graph A, if you look at its peak, it is at, oh, I cannot draw. It's about 15. But if you look at graph B, the peak is at about 12. So the mean for graph A is greater. Okay. The next question says which one has a greater standard deviation. Well, you look to see which one is wider. And as you can see, B is wider than graph A. All right, the scale test for New York State Grade 4 Common Core Mathematics. Tests are normally distributed. The normal curve shown below represents this distribution. What is the mean test score? We're going to estimate the standard deviation of this normal distribution. So if we look at this graph, the peak is about 305. Okay, so I have a dotted line there. And we're going to estimate the standard deviation. So we can go out one standard deviation. When we go out one standard deviation, we're going to look at where the graph starts to change its curve. So I have these inflection points here. So if we go down, this point here is about 330, 340. This is about 345 here. All right. So I can just use that point to figure out the standard deviation. This point is about 305. All right, so if I go from 305 to 345, if I subtract that, I get 40. So we can say that the standard deviation is about 40. This is just an estimate. So if you were to look at a graph, I don't expect you to get it hit, right on the spot, because you're really estimating these points. But that's how you can tell what the standard deviation is. When you use the empirical rule, you should know that 68% of your scores are one standard deviation away. So when I say one standard deviation away, you're going to take 305 and you're going to add and subtract the standard deviation. So one standard deviation will give you 345 going above, and it will give you 265 going below, because you're going to subtract off that 40. So that is how I got 265 and 345. 95% is going out two standard deviations. So this is the calculation for two standard deviations. So you're going to take the mean, add and subtract 2 times the standard deviation, which is 40. And when you calculate that out, you'll get 225 and 385. When you go out 3 standard deviations, it will be the mean plus or minus 3 times the standard deviation. So in this case, this will be 305 plus or minus 3 times 40. When you calculate that out, you get 185 and 425. This is what you call the empirical rule. So you use this for 3, you use this for 2. One standard deviation will be 1 plus or minus this. So the one thing you should know about the standard normal distribution is that it has a mean of 0 and a standard deviation of 1. You can figure out areas underneath the graph by converting a value to a z-score. The z-score is the value minus the mean divided by the standard deviation. So x minus mu divided by sigma. The total area underneath the normal curve will always be 1. And when you do it, I can show you how to do it with the table, how to use StatCrunch, and how to use my Excel template. So if you look over here, the cumulative area is close to 0 for z-score is close to negative 3.49. So this is negative 3.49, but as you can see, it doesn't have much area to it. It's close to 0. As the cumulative area increases, the cumulative area increases as the z-scores increase. So if you look at this next one, let's say we are now at z equal to 0. We want to find out the area to the left of that. So this is this area here. Well, as you can see, z equal to 0 splits the graph in half. So this is 50-50. So this will be 0.5. As we get closer to 1, the cumulative area, let me say that again. The cumulative area is close to 1 for z-scores close to z equal to 3.49. So this is 3.49. We're going to look at all of this area, and that's going to be close to 1. All right, so let's go through a problem. I'll show you how to use the table first. We're going to find the cumulative area that corresponds to a z-score of 1.15. So I like to draw pictures. So here's a picture. I have 1.15 on the graph. And to find that in this table, this is called a z-table. So to read a z-table, the z is always 3 numbers. Okay, so you look for the first 2 numbers going down, and then you look for the last number going across. Okay, so the z will always be x point xx, right? So in this case, it's 1.15. So the first 2 numbers we're going to look for going down. That's 1.1. That's here. I have it in yellow. And then the last number, which would be 0.05, will be going across. So we go across and we get to here. Where these two numbers meet up in the body of the graph is the area. So as you can see, we get 0.8749. That's the area to the left of 1.15, 0.8749. Let's look at another problem. We want to find the cumulative area that corresponds to a z-score of negative 0.24. All right, so negative 0.24, we're going to look up negative 0.2 going down the z column, and then we're going to look up the 4 going across. Where these two meet up in the body of the table is the area, so it's 0.4052. That's the area to the left of the z-score negative 0.24. So the way you find areas underneath the standard normal curve is you always should sketch the curve and then shade the area that you're interested in. To find the area to the left of the z-score, you find the area that corresponds to z in the standard normal table, and that's what I just showed you. So for example, in this one, we want to find the area to the left of z equal to 1.23. We use the table and we got the area to be 0.8907. If you want to find the area to the right of a z-score, you're first going to find the area to the left of the z-score. Whatever area you get, you're going to subtract from 1. So in this one, they want you to find the area to the right of 1.23. Well, I know the area to the left is 0.8907. So to get the area to the right, which I have in blue, I'm going to subtract 0.8907 from 1, and I get 0.1093. The reason why you subtract it from 1 is because if you take the beige area plus the blue area, that's the whole curve. So that's 1. The area underneath the curve is 1. Now, if you want to find the area between two scores, it's kind of tricky, but it's just a little extra work. So let's say I wanted to figure out the area between negative 0.75 and 1.23. This is a standard normal. I want this area in blue. The first thing I'm going to do is find the area to the left of 1.23. That area is 0.8907. Then I'm going to find the area to the left of negative 0.75. I get 0.2266. And then I subtract these numbers. I take 0.8907 minus 0.2266. I get 0.6641. So the area between these two values is 0.6641. All right, so that's how you do it with the table. And when I was in college, that's how I learned. I learned with the table. We didn't have all this technology that you have today. So I'm going to show you how to do this in StatCrunch, and then I'm going to show you how to use my Excel template. So let's look at this first problem. It says find the area under the standard normal curve to the left of z is equal to negative 0.99. So this is what we're looking for. Probability, or find the area, same thing, that z is less than negative 0.99. So what we're going to do is, I already have the answer up there, and that's based off the standard normal table. But let's go ahead and use StatCrunch. So we're going to go to Stat, we're going to go to Calculators, and then we're going to go to Normal. You have to make sure that your mean is 0 and your standard deviation is 1, because this is a standard normal distribution problem, and they want us to figure out negative 0.99. So we can change this less than to greater than, but in this case it is less than, so I'm going to keep that, and we want negative 0.99. So I'm going to type that in this box here, and I hit compute. And as you can see, once you hit compute, the graph comes up and it gives you the answer. Gives you the answer in that box, 0.161, and then you can round that 8 to a 1, so that 0 to a 1, so it's 0.1611. Okay. Let's do another one. This time I want to figure out the area to the right of z equal to 1.06. You can do this with the table, but I'm going to go ahead and use StatCrunch. So I'm going to go to StatCrunch, and I believe the problem said 1.06. Yes. All right, so My mean is 0. My standard deviation is 1. I'm going to change this to greater than, and I want 1.06. I hit compute, and voila. You get 0.1446. And that's the answer we got here, 0.1446. And it even gave you the graph. It looks just like the graph that we have up there. And then the next one is find the area between the standard normal curve between negative 1.5 and z is equal to 1.25. All right, so we go back to StatCrunch. If you look here, you have to click on between, and then it'll give you the area between. So in my problem, I have negative 1.5. So I'm going to put negative 1.5 and then a positive 1.25. Okay, so make sure you hit the between, and when you hit compute, I forgot to put the negative, sorry, negative 1.5. All right, so as you can see, you get 0.8275, and it gives you the graph. If we go back to my same thing, we get 0.82, well, they rounded 0.8276. All right, so let's go ahead and do this. I'm going to go back to the previous problem, the first one, and I'm going to use my Excel template. So this is my Excel template for normal distribution. We have to type in this pinkish box. We have to type in the mean, the standard deviation, and what value I'm looking for. So in my template, it's going to be called X, not Z. And you'll see why, because when we get into later chapters, it won't be called a Z value. So the mean, since we're dealing with standard normal distribution, the mean is 0, the standard deviation is 1. And I'm going to go back to this first problem, and then we want the area to the left of negative 0.99. So I'm going to type in negative 0.99. And as you can see, the answers populate over here in the yellow. But you have to figure out which one is which. So we wanted P, the probability that Z is less than negative 0.99. So that will be this first box, because I have a less than here. So 1.611, that's what we got when we did it with StatCrunch. And you can also do it by hand. Go to the next problem. This one, the probability to the area to the right of Z is Z is 1.06. So go back. Mean and standard deviation stays the same, 1.0 and 1. I type in 1.06, and I want everything greater, so that would be this box here. And that yellow is 0.14457 or 0.1446. And then the last one, we have the area between Z negative 1.5 and Z 1.25. So in this case, I won't type anything in X. What I would do is I would type in my lower number and then my upper number, okay, because it's in between two values. So I'm going to go to this L and U, and my lower was negative 1.5 and my upper was 1.25. And you want this box here where X is in between these two numbers is 0.8275, and that's what we calculated there. So technically you can write this as Z is in between these two numbers, so you can see how it looks when you do it in StatCrunch or my Excel template, and you do it here, it'll be Z is greater than 1.06, so they want everything to the right of that. Okay, that's the end of this lecture.